Okay, so by this point we have a point estimate from our sample and we've established a confidence level. So time to calculate the margin of error. The margin of error represents the value to add to each side of your sample statistic or point estimate to generate the confidence interval for your population parameter. And the size of the margin of error is determined by two things: the confidence level and the standard error. So if we go back to our employability example, we have this information at our disposal and we want to calculate the margin of error from this sample with a 95% confidence level. Now, you might be looking at this and thinking, wait, I get that we know the sample mean, the sample size, and we've established an alpha of 0.05, but where did that sigma value come from? So I do have to clarify that for this example, we're assuming that we know the standard deviation of the population, since we need it to know the width of our sampling distribution of the mean. Knowing this value, though, won't always be the case, and we'll cover those scenarios as well, so don't worry about that for now. Let's just continue with this example. So if we want to calculate the confidence interval, then we can use this formula, which seems unfortunate, but it's actually quite simple. We have the point estimate first, which is our x-bar, or sample mean, and let's just plug that into our formula, plus minus the margin of error, which is all of this. Now the first part right here is the z-score that the confidence level represents, also known as the critical value. So if we look at the standard normal distribution, or z-distribution, and add that confidence level of 95%, what we want to know is, what's the z-score at the edge of the area here? In other words, how many standard deviations away from the population mean does my confidence level allow my sample mean to be? That's what this number will represent. Now, to get this number traditionally, you'd have to look up values in this weird matrix type t-table, and you can still do that, but we don't need that here. We have Excel. And guess what? We know how to calculate this number already. Let me reframe the problem to solve to see if you can figure it out. We need to find the z-score at a given cumulative probability. Does any formula ring a bell? It's the norm.s.im function. And this right here is just the cumulative probability up to alpha divided by 2. That's where the formula gets the z underscore alpha divided by 2 from. Now this is going to return a value of negative 1.96, which is correct, but adding and subtracting a negative number is a little bit confusing. So a lot of the time you'll see this instead, which is just the cumulative probability of 1 minus alpha, or from negative infinity all the way up to the end of our area on the right here, which does get us the same z-score. It's just positive and easier to work with or think about. So that's one component of the margin of error. Let's go ahead and plug that value into our formula. But the other, as we can see from our bullet here, is the standard error, or the standard deviation of the sample means. And if you think about it, it makes a lot of sense. We know how many standard deviations away from the population mean we're allowing the sample mean to be based on our confidence level. All that's left is to know what the value of a standard deviation actually is. And we've seen how to calculate that already, and we can see it in the formula. It's just going to be the standard deviation of our population divided by the square root of our sample size, in this case 9.23. So let's plug that into our confidence level formula, and we get a margin of error of 18.09. And just like that, we have our confidence interval. So we can now say that we're 95% confident that the average employability scores of our MBA students, past and present, at the beginning of the program will be of 239.9, give or take 18.09. In other words, roughly from 222 up to 258. Which does also mean, of course, that there's a 5% chance that the real value is actually outside of that interval.